It begins with something almost insignificant, a single step, quiet, ordinary. But beneath that calm movement, a powerful biological reaction is already underway. Scientists often describe walking as a metabolic switch. The instant your foot touches the ground, your body shifts from rest into action. Multiple systems activate at once, preparing for movement and rising energy demand in ways most people never notice. Within seconds, your muscles send chemical signals to the brain asking for fuel. The message is subtle, but urgent. Your cardiovascular system responds immediately. Heart rate rises, breathing deepens. Blood flow is redirected toward working muscles. It feels easy, but internally, your metabolism is waking up. Almost right away, your cells increase production of ATP, the energy molecule every cell relies on. Enzymes involved in glucose and fat metabolism begin mobilizing fuel. Nothing dramatic yet, but the transformation has started. What's remarkable is how fast the body commits. Even within the first minute, your physiology adapts for efficiency. Muscles become more responsive, energy pathways activate. Your internal engine prepares for a deeper metabolic shift that only happens with continued movement. And later, you'll see why that shift matters so much. The moment you start walking, your body enters what scientists call an acute activity response. This is the transition from rest to motion. At first, your cells rely on the fastest fuel available, glucose stored in the blood and muscles. This ensures energy demands are met instantly. But within minutes, hormones begin to change. Adrenaline rises slightly. Not enough to cause stress, just enough to increase alertness and readiness. This small shift helps your body mobilize stored fuel more efficiently, even if you're just walking down the street. Meanwhile, your muscles consume more oxygen. Your lungs respond automatically, pulling in deeper breaths. Metabolism begins to rise, increasing calorie burn almost immediately. Walking gently nudges your metabolic rate higher without overwhelming your system. And here's the interesting part. Even if walking feels relaxing, your cells are operating at a completely different rhythm. Fat-burning pathways begin opening pathways that grow stronger the longer you stay in motion. Fat cells, known as adipocytes, are often misunderstood. They're not passive storage units. They're metabolically active, hormone-responsive cells. When you start walking, fat cells receive signals that energy demand is increasing. That signal alone begins changing their behavior, even before fat burning fully ramps up. As muscles warm, they release myokine signaling proteins that communicate directly with fat tissue. These messages tell fat cells to prepare for fuel release. This preparation phase is crucial. It primes fat cells for lipolysis, the breakdown of stored fat into usable energy. At the same time, insulin levels begin to fall. Because muscles absorb glucose without insulin, overall insulin concentration drops, and that matters. Lower insulin removes one of the main locks that prevents fat cells from releasing stored fat. Inside each fat cell, triglycerides are stored like tiny droplets of energy. When demand rises, enzymes such as hormone-sensitive lipolysis activate. This marks the start of lipolysis. Triglycerides split into fatty acids and glycerol. These molecules enter the bloodstream and travel to working muscles. This is the moment fat officially leaves the cell. Though microscopic, the impact is enormous. This is how fat cells begin to shrink. Muscles absorb fatty acids easily. Inside muscle cells, these fats travel to the mitochondria, the metabolic engines of the cell. There, they enter a process called beta-oxidation, where stored fat is converted directly into usable energy. The process is steady, controlled, and extremely efficient. Walking is uniquely suited for this. Unlike high-intensity exercise that relies heavily on glucose, walking gives the body time to activate, transport, and burn fat without stress. Inside the mitochondria, fatty acids are broken down step by step, releasing energy at each stage. These reactions don't just power movement, they improve mitochondrial function over time. With regular walking, cells produce more mitochondria, a process known as mitochondrial biogenesis. More mitochondria mean better endurance and a faster metabolism. Even more fascinating, mitochondria send signals that influence inflammation, hormone sensitivity, and aging. A simple daily walk isn't just burning calories, it's upgrading your cellular network. Researchers have searched for the point where warm-up becomes meaningful metabolic change. Again and again, 30 minutes emerges as that threshold. Early in a walk, glucose dominates. But as time passes, metabolism gradually shifts toward fat oxidation. This shift isn't instant. It builds progressively. Around the 30-minute mark, it becomes fully established. Hormones align. Insulin stays low. Adrenaline supports fat release. Glucagon encourages the use of stored energy. Oxygen consumption stabilizes, and that's critical. Fat oxidation depends on oxygen. Once oxygen delivery is steady, cells can burn fat efficiently without rushing. High-intensity exercise often disrupts this balance. Walking allows it to thrive. That's why 30 minutes isn't random. It's a metabolic milestone. Your body is no longer warming up. It's fully engaged in fat oxidation and internal recalibration. As glucose availability declines, your body adapts. Enzymes shift. Fat-burning pathways become more active. You may not feel the switch happen, but internally, it's one of the most important steps in sustainable fat loss. Consistency amplifies this effect. The more often your body performs this sugar-to-fat transition, the more efficient it becomes. Over time, fat becomes a preferred fuel, even at rest. This is why people who walk daily often report better energy, sharper focus, and improved body composition. Quick pause, comment below. Did you know that most fat you lose leaves your body through your breath? When fat is burned, its carbon atoms bind with oxygen and are exhaled as carbon dioxide. The rest leaves as water. Fat loss isn't melting, it's chemistry. Fat cells shrink as their contents are transformed, molecule by molecule. Walking daily compounds this effect. Blood flow to fat tissue improves. Hormonal signals become more effective. Gene expression shifts away from storage and toward breakdown. This is long-term fat loss driven by biological consistency, not intensity. Beyond metabolism, your brain changes too. Neurotransmitters like serotonin and dopamine rise gently. Focus improves. Mood stabilizes. Walking also increases BDNF, a molecule that supports brain health and protects against cognitive decline. Appetite hormones recalibrate. Inflammation decreases. Insulin sensitivity improves. Walking quietly fine-tunes your entire system. High-intensity workouts have benefits, but they rely heavily on glucose and raise stress hormones. Walking keeps stress low while fat oxidation stays high. It's sustainable, accessible, joint-friendly, and incredibly effective. By the end of a 30-minute walk, changes continue long after you stop. Fat cells have released energy. Mitochondria have burned it efficiently. Hormones and brain chemistry move toward balance. What feels simple is actually a powerful internal reset. With daily repetition, your body becomes metabolically flexible, efficient, and resilient. Walking isn't just exercise. It's a biological signal, and every step reshapes your health from the inside out. If this helped you understand your body better, like, subscribe, and share it with someone who needs a simple, science-backed way to improve their health.